For most people, the story of the Second World War is told through tanks, aircraft, and battlefronts. But one of the most consequential struggles of the war unfolded quietly in fields and gardens. Entire agricultural systems were pushed to the brink of collapse. Fertilizer factories were redirected to explosives production. Transport networks were shattered. Farmers were expected to produce more food from increasingly exhausted soil with fewer tools than ever before. In that environment, a small number of agricultural researchers and practical farmers rediscovered something that modern agriculture had almost forgotten. Soil is not simply dirt that needs chemicals added to it. It is a living biological system. And under wartime pressure, they began using a simple liquid made from fermented organic matter and microbial life, what today would be recognized as a form of microbial compost extract, or compost tea. To many observers at the time, the results looked almost impossible. Soil that had stopped producing crops began recovering within weeks. Plant growth returned without the application of conventional fertilizer. The explanation was not magic, it was biology. Yet after the war, this approach largely disappeared from mainstream agriculture. Industrial fertilizer replaced it, and the wartime experiments faded into obscurity. Understanding why requires looking closely at the conditions of wartime farming, the science behind living soil, and the economic decisions made in the decades that followed. The wartime fertilizer crisis forced farmers to rethink what soil actually needs. Before the war, modern chemical fertilizer was already reshaping agriculture. Nitrogen synthesized through the Haber-Bosch process had allowed farmers to dramatically increase yields. But that same nitrogen chemistry was also essential for explosives manufacturing. When war began, factories producing ammonium nitrate and other fertilizers were redirected toward munitions production. In both Allied and Axis countries, agricultural nitrogen became scarce almost overnight. Britain faced the crisis particularly sharply. The island was dependent on imports for both food and fertilizer. German submarine warfare targeted those supply lines, forcing the British government to launch the Dig for Victory campaign, turning parks, lawns and vacant land into food production. But these improvised fields often had a problem. The soil was biologically dead or heavily compacted. Urban soil had been neglected for decades. Military construction projects and bombing damage further degraded farmland. Simply adding more fertilizer was not an option. There wasn't enough of it. Agricultural scientists began studying something that had been largely overlooked during the chemical fertilizer boom. Soil microorganisms. They recognized that many soils were not failing because they lacked nutrients, but because they lacked the biological systems that make nutrients available to plants. That realization led to renewed interest in biological soil restoration techniques. The basic principle was straightforward. Healthy soil contains billions of bacteria, fungi, protozoa, and other microorganisms in every handful. These organisms break down organic matter and convert nutrients into forms plants can absorb. When soil becomes degraded through overtilling, chemical overuse, erosion, or compaction, those microbial communities collapse. The wartime solution was to reintroduce them. Farmers and researchers began brewing liquids made from compost, manure, plant material, and water. These mixtures were allowed to ferment, encouraging the explosive growth of beneficial microorganisms. When diluted and applied to soil, the liquid effectively inoculated the ground with living biology. The results were sometimes dramatic. Microbial activity returned to dormant soils. Organic matter decomposed more rapidly. Nutrients that had been locked in the soil matrix began cycling again. Crops responded quickly, not because new fertilizer had been added, but because the soil's internal nutrient system had been restarted. In many cases, farmers discovered that soil long considered exhausted still held large reserves of minerals. What it lacked was life. The microbial liquids changed that. If you value deep historical analysis like this, stories that reveal the overlooked systems behind survival and resilience, subscribe to Logistics of Survival and share this video with others who appreciate the hidden lessons of history.